Hi everybody, just wanted to give you a couple of applications for a 2-bit up-down counter. What we'll do here is we'll put in a little diagram of the up-down counter. It'll have 2 bits coming out, A and B are the bits, and it will count up or down, up, not down, and we'll have a little clock input. And then what we're going to do is we're going to take the outputs and run them through a decoder. We'll make a 2 to 4 decoder out of it. It'll have an enable, which we'll assert as 1. And then the output will be function 0, function 1, function 2, and function 3. And now we can define the functions any way we like. For example, if u is equal to 1, and we can start to count up, then we count through function 0, function 1, function 2, and function 3, and we can define these functions to activate various things. Let's see, what would be a good example. Suppose you wanted a railroad crossing. That's a good example. So in the railroad crossing, we'll have the train is coming, and so what happens is we start to ring. This is for the railroad, X-I-N-G, railroad crossing. And so we hear the train is coming, and it goes ding, 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 ding. And then what you want to do is you want to have the ringing continue, F0, and you want to add to that the gate is down. That's after a small delay. And then you want to go and add to that F1 the idea that you're going to have the blinking lights. So you have a physical obstruction, a blinking visual obstruction, and an aural indication. And finally, after the train passes, we're going to undo the gates up, and so we're going to do essentially F2 inverted. Lights go off, the gate comes up, the ringing stops. So that's everything. And that's a simple sequence. Now let's try another one. Let's do a countdown. So we'll do u equals 0, countdown. So it's now function 3, function 2, function 1, function 0. So let's call this the ignition sequence started. So ignition sequence started for our Saturn V booster rocket. We're going to the moon, right? Saturn V booster rocket. Saturn V booster rocket has 6.2 million pounds of propellant, which is used to create 680 metric tons per F1 engine, and there are 5 of them, giving a grand total of 7.5 million pounds of thrust. That is 3 tons per second of propellant. That's a lot of propellant, and that's liquid oxygen and kerosene, rocket grade kerosene, of course. And so what we'll do is we'll ignite. So the igniter active. That's our ignition sequence started. Now we'll take the LOX. This is not the smoked fish, it's a liquid oxygen. And the LOX valve will open. In comes your oxidizer. To start our turbopumps, we use a fuel that ignites on contact, known as a hypergolic fuel. For students of history, you might recognize this as being T-Stoff and C-Stoff for the Messerschmitt 163, a rocket plane used by the Nazis in World War II. Same sort of thing is used to land the lunar excursion module, or actually to take off with the lunar excursion module, because you really want something reliable that you know is going to ignite, or else your astronauts are stranded on the moon, and that's very bad PR. Well, the hypergolic fuel goes directly into the combustion chamber. Gets your turbo pumps running so that you can pump the 3 tons per second of propellant. And then what? And then comes the main fuel. And that valve is open, and everything starts to shake, and we have liftoff. Liftoff of the Saturn V rocket, ready to go to the moon. So ignition sequence started. 3, 2, 1, 0, blast off. Kapowie. And that's what you can do with a little finite state machine. Thank you.